There we go. Go ahead and get started on exploring the InfluxDB ecosystem, including our integrations, libraries, plugins, in general, awesome additions for time series data management. So as I already said, I'm a developer advocate at Influx Data. You guys are welcome to connect with me on LinkedIn. If especially you don't feel comfortable asking questions in this kind of an environment, feel free. I've been a front-end engineer before that for about 8 years. I originally started working in the original AngularJS before it swapped over, and then I just started working in React about 5 years ago. Nowadays, I end up coding a lot more in Python because we just happen to work a lot more with data analytics nowadays in my company. So the agenda today is going to be an intro to time series databases, and then it's a general introduction to InfluxDB. I will say this, a lot of time series databases are very similar in what they tend to allow you to do, how they store their data. We're not that per se different, except for normally the integrations that we do. Those are normally the big differences. Then we'll go into data collection. That's going to be the client libraries in Telegraf, how to integrate with Pandas, how to integrate with Grafana, a big integration that people love to do, and then a quick brief overview of Superset, Tableau, and the great beyond. Just a few of the things that we're working on. And then at the end, I always add resources, so you can just take one photo at the end and get all your resources. So why a time series database is important. So first things first, what is time series data? So the best example I always give is it is an IoT device that's constantly streaming you time data. It's saying at this time my pressure is this amount, or at this time the amount of light I'm receiving is this amount. Sometimes it's also more like abstract. It's more, your server infrastructure. It's your devices telling you when someone's pressing a button on your website. It's an API call, stuff like that. But in general, time series data is something where you care about querying on that time. There's lots of data that has timestamps where you don't per se care as much. So for example, it's not uncommon for us to store the last time a user logged into our website. It's just not an uncommon thing to have in a DB. Now, that doesn't mean, though, that we're querying on it. That's just more something that happens to have a timestamp that is there, but that's not necessarily something that you're actively querying on to figure out, unless, of course, you're trying to figure out like a bug or something. You don't normally, per se, care about the last time people logged in. Caveat being, in the gaming world, that actually is a big thing that they do tend to query on. So when it comes to that, we have our metrics. Those are definitely those IoT devices. That's regular over time. Anybody who's ever worked in the IoT world, you know your devices are constantly noisy. That's all they do. They just send you data constantly all the time. Events are irregular. Those are like a button click on your website. Who knows when the button will be clicked? It couldn't have been clicked in the past 2 weeks, but now it's been clicked and it doesn't work, and you're getting an alert about it. And then traces, which are basically a full event. So that's something like, you click on the button and you're taken to a new website and it does this, and that's a full event, a full trace in a distributed system. So the other thing to note that I always like to talk about, because you're going to hear this a lot, is that other DBs can store time series data. That's true, technically. You can store anything in a DB if you're really aggressive about it. The biggest problem really comes down to, normally you store time series data at the very least in a NoSQL DB. The reason being is that SQL DBs are fantastic at storing their data for a really long time and keeping it really, what's the word here? They don't condense it down. You want your full rows. You want all that data. That's why you're storing it in your SQL DB. But time series data isn't really like that. In general, sometimes NoSQL data is kind of like that, where you actually sometimes want to manipulate it a lot. You want to drop it. You want to condense it down. We call that downsampling normally. That's like saying, give me the average amount of light that was on my sensor today. I don't need all the minute every second details of light. I just want the average on the hour. That's all I desire. That's downsampling. And SQL DBs just weren't really built for that. That's not a problem for them per se. It's not a bad thing. They're good at what they do. That's why 90% of DBs on the internet are SQL-based. So it's not a huge deal. But you'll also hear Elastic and MongoDB, which are NoSQL DBs, claim that they can store time series data, which they can. They're actually, depending on the scale and use case, they're actually pretty good for it. But we do normally like to mention that they're a little bit better for document, and obviously Elastic is a lot better for search. We're definitely not a search DB. That is not our wheelhouse. So that's why I kind of like to show this, this comparison chart, because I find I will say this, though, a lot of people, you just end up in the DB that you're comfortable in. Like, I know a lot of people who store their time series data in MongoDB because they've worked in it for 10 years and they know it like the back of their hand. And those people normally, by the way, have really good solutions because they've done it for so long. The person who just came into it greenfield and tried to build it out, they're not having as much of a fun time. So this is a typical architecture in deployment. And again, although it says InfluxDB 3.0 at the top, this is pretty common for most time series databases. You have your data source. That's going to be those metrics, sensors, events, all that good stuff. Your data collection. That is going to be things like client libraries, which I'll go into, as well as Telegraf, which, by the way, is database agnostic. It can be used in any DB. That's why it's so popular. And then you have your data storage and transformation. The data storage is pretty straightforward. It's called you store data. I know, who would have thought? So, and then from there, the transformation can be things like that downsampling I was mentioning, SQL queries to look for very specific points in your data, just as you would with a SQL query in general. And then finally, data visualization and analysis. So that's where those integrations come in. We don't necessarily give you all the tooling to do that because there's lots of amazing solutions out there that people prefer to use and are more comfortable using. But yeah, normally what you're doing is you're storing your time series data and then you're querying it back out into your preferred platform for whether that be visualization or, figuring out anomaly detection and such like that. Just depends on your use case. So some of the things that InfluxDB 3.0 in particular is a little different is that we are now built with the Apache Arrow project and Parquet file format and data fusion, which all of this basically means that we can now do a SQL support. That's the big thing. Yes, we're very good now for also being a single data source for storing things like logs and traces, which we weren't before. Before we were really only good at metrics. Now we can do all three. The schema on write was always that way, so that's not really a big difference. And then the Parquet file format is a lot more I'm basically just going to call it better at condensing the data, so basically the storage costs are lower, which is always a good thing for our clients, and in general, people really like to, save money. It's a big deal, big win. But the biggest thing is the SQL support because that allows for a lot of the integrations I'm about to talk about. So data collection. So when it comes to Telegraf, so funny enough, actually a lot of people use Telegraf and they don't know that InfluxDB created it or that we maintain it or anything like that because it's fully open source and it's definitely very much driven by the community. There's about 300, in my next slide I'll show you I think a few of them, but there's about 300 different endpoints for collecting your data from. And it's simple to configure, extremely flexible. I really suggest if you're working ever with time series data, you check out Telegraf first, see if there's something available for you. Yeah, here we go. So here's a few of the plugins that we offer already. And a lot of these we built for ourselves, or not for ourselves, we built for our customers ourselves, but a lot of these are also supported by their own companies. So like down here, you can see like AWS CloudWatch and Google Cloud PubSub. Those were created by AWS and Google engineers. A lot of these are created by the companies because they find extreme value in being able to be like, hey, look, we connect with Telegraf. So you can store all your data in a time series DB with Telegraf. Go have fun. So a lot of these have been created not just by us, but by the overall community. And in general, like I said, employees at these companies. I know because we talk to a lot of them online as well. So this is obviously something that's really great to take a look at. We also support things like the Open Telemetry Project, et cetera, et cetera. So I'm not going to go super in-depth in the client libraries just because depending on the language that you are coding in is going to be slightly different. But the basics are all pretty much the same. It's basically the ability to write your data and query it right back out. There's a few other things here, things like deletion or being able to look at your overall database, like retention policies and stuff like that. But for the most part, it's the ability to write your data in and query it back out in the language of your choice. So what I normally say is, first you go to Telegraf. No plugin is available that you desire. No big deal. You pick the language of your choice. You go ahead and just write a script yourself. It's very straightforward. It's very easy. A lot of people end up in the Python library because we also allow you to pull it back out with a Pandas data frame, which is an obvious great integration for people. So yeah, that is the pretty much basics of that. I have a link towards the end where I basically link the Influx community where you can find all these, but there's tons of documentation about them. It's not super hidden at all. So when it comes to data storage, this is normally how things are stored, not only in Influx, but in general in time series databases. We normally have a measurement. That's the actual thing that you're measuring. That could be your light. In this one, it's the server. Your tag sets, those are normally string values. So for this one, it had a host name and a location. So those are stored as strings. And then you have your field sets. Those are normally integers, as well as the, I guess you could say, the integers of things that you're tracking. So for this one, it's got the CPU and the memory. And finally, a timestamp, which is a Unix Nano timestamp when it's actually stored. So this is a very basic format in how the data is stored. Tags, fields, timestamp, and measurement. The only two that are actually required is the measurement, the timestamp, and one field. Everything else is optional. And you can have up to 200 of these. Pandas plus Influx. So because we work with the Apache Arrow project, we use the Flight SQL client to basically hook up into our client libraries. And what this one's doing here is we're using the Flight SQL client. We're feeding it a token that we get from the InfluxDB from the website. And from there, we're also giving it our bucket name. So in this one, the bucket's name is factory. And from there, we're doing a query against it, where we select from the IOX data machine where the time is basically less than now in an interval of 1 day. So basically, give me all the data for the past day. Go ahead and query those endpoints, put this in a table, and then print the table. And that is basically what that is doing right there. That is the printed table. So this is pretty straightforward. Again, there's tons of documentation around this. This is, I think the only thing I've left out of here is all of the imports, but those are really easy to find, so that's not really that big of a deal. And after that, from there, you can do your data frame, convert the table to pandas. Super straightforward, very easy. Thank goodness. You can also sort the values, for example, by time, and then I print the top head. The other thing you could technically do, these are Arrow utility functions, by the way, so this is not like Pandas specific. These are just a few different things that you can do. You could save the table to a Parquet file. You could load the table from the Parquet file if you were to like download a Parquet file. And you can also do some PyArrow aggregation as well, and then convert that to pandas after you've done that. So for example, this is that table result. So this is the first 20 values, just to make sure that it returns multiple points for each sensor here. So as you can see, we've got a sensor ID. It's got some temperature and some humidity, as well as a timestamp. I'm trying to remember what the CO stands for. That's OK. We'll just ignore it for now. It's a small value, I can tell. And then we have our columns on the left side. But yeah, this is basically how this would end up looking. Anybody who's ever worked in Pandas would recognize this as a Pandas table. Very nice and straightforward, only about 10 lines of code, and you've got your data out. And another thing that Pandas allows you to do is that downsampling that I was talking about before. So with this one, they're downsampling on a group of 10 minutes. So basically, for every 10 minutes, give me the mean. And then I think they're actually, if I remember correctly, we're dropping the data on this one as well. I wrote this with my coworker like 6 months ago, and then I keep looking at it and being like, yeah, I remember that. Isn't that how all coding goes? So, and then from there, we just reset the index. And this is how that table ends up looking. So this is the first original one on the left. The right side is the downsampled one. So as you can see, now we are getting it in 10-minute intervals because the time is now our column. And then from there, we have our humidity and our temperature averages. And I assume the CO is the average as well. And so basically from there, it's very straightforward to downsample. Obviously, this is something that's very nice. And then I don't know if I didn't include in this, but we actually also include information on how to send the data back up into Influx. So you can pull it down, you can downsample in Pandas, and then you can push it back up, either normally into a new DB or bucket, something that might be called like downsampled data bucket instead, so that you don't shove it back into where you just got the undownsampled. So now Grafana and Influx. So we have a pretty close relationship with Grafana and oh my goodness. We have a very close relationship with Grafana. We work with them a lot. So although up here it's saying that I'm talking about InfluxDB 3 when I'm talking about this, if you are on InfluxDB 2, or which by the way, good news is that we're going to have an open source for InfluxDB 3. It's coming out later this year. But if you're on the open source, right now you're on the 2. And if you're in the cloud 2, we do also have Grafana hookups for that as well. It's the same kind of deal where it's a very specific plugin. But this is our new plugin for the IOX, which is SQL-based. So basically just make sure that you have that enabled when you create an account. Pretty straightforward. We, of course, suggest the Grafana open source because we like open source. You can also use the cloud or whatever you're comfortable with. From there, you basically are going to configure your Grafana data source. When I took this screenshot at the time, this was technically not fully approved. It doesn't have that little red warning anymore, thank goodness. So basically, you select the flight SQL data source. And from there, it's pretty straightforward. You're just creating a flight SQL connection. So with this one, you just want to make sure that your auth type is your token, and then you add a token. So I haven't showed it here, but basically in the UI, it's very straightforward. You can just select like your bucket, and then you can just be like, give me a read and write token. And that would be how you would get your permissions. That's how you, in general, get permissions to hook up to integrations. Authentication is very important. I just haven't showed it here in like a photo or anything, but it's very easy to find. But basically, you select the token, you select your port. For me, this was taken on a coworker's laptop, so he was in EU Central. I'm normally in the US West, but whatever. And then we have our bucket name with the value of your bucket name. So my bucket was called Northbound when I took this photo. I have lots of random buckets in my Influx account, let it be known. Some of them are named even more fun things than Northbound, which is a very strange name now that I think about it. From there, you select time series as your visualization. And in this one, in the bucket, we're storing generator ID and basically the amount of fuel that the generators have. So this is anybody who's ever seen a SQL query, this is a SQL query to get that data out. The time range is a Grafana global value. It allows you to make your time ranges dynamic. There are other types that you can use as well, but this was the most straightforward for our query. Then you navigate to the transform and partition values. And all this, by the way, is available like online. Like this is not just something that I have here in my slide deck. This is like a blog. It's in GitHub and like a notebook. It's all over the place. Because I know it can be a little bit confusing to follow along like this. But basically, this is how we expect our graph to look. We have our fuel for generators 1, 2, and 3. And in case you're wondering why it looks so weird, it's because it's randomly generated data from, these are not real generators. That would be kind of cool if they were. But no, I don't have like a generator full of gas sitting at my house that I'm monitoring. And here is the actual try it yourself. So this InfluxDB IOX Quick Start, yes, it includes the Grafana one that I just talked about. It also includes a superset one. And then I think it also has like Docker as well. It has a few others. Me and my coworkers work on these, and then I don't see them for like 2 months, and then I have to go back and look at the quick starts and see what we've added. So going into superset, Tableau, and more. So we now have a superset integration. We're just currently awaiting on our PR to go in, and then we'll actually be on the superset website. Very exciting. But basically, for those of you guys who don't know, superset is a completely open source visualization library. It's kind of like Grafana, if I'm being honest. It's built, though, by the Apache project. So because we're already integrated so much with other, obviously, Apache projects, we do really like superset. We also work with the company that kind of does them as like a, like an enterprise version as well. So yeah, this is coming pretty soon. Outside of that, we do actually have it in the quick starts on how you can just build this yourself without following the exact superset docs, because we built it and then we, a month or two later determined that, wait a minute, this is not like on the official website. We should probably get that done. That's the kind of, that's just how engineering works. So for Tableau, I'm linking a thing here for the blog, but it's very straightforward to get it set up and get going. This is also available on our documentation. But basically, some of the big highlights here is that we're using a JDBC driver to hook up to Tableau. And it allows us to still have that high performance capability of the Apache Arrow project and efficient data transfer protocol. Basically, this is a lot of words to just say the data will go very, very fast into Tableau, which is what you want. You want your data to quickly get to the integration and platform that you desire. And by using this JDBC driver, we are basically doing it very, very quickly. It will allow for real-time visualizations, which is really important. Basically, a lot of people sometimes use Tableau as a real-time analytics platform. They can watch things in real time. The graphs, they move and they're colorful. It's very fun. And so with this, it allows you to still have those real-time visualizations. And it's a seamless integration. I think the total amount of steps taken to get this set up is like 5. So it's very, very straightforward, very, very easy. The two other that we're currently working on is Power BI. We're hoping to have it done by the end of the third quarter. It's been a little more tricky than I think the DevRels or engineering thought it would be. And Grafana continues to work on adding more SQL to our existing InfluxDB plugin. There's no ETA as of yet because we don't work. I'm not on Grafana's engineering team, so I don't quite know what's on their schedule, but we've been talking to them and we know that they're working on stuff. I think they're probably going to announce it for their next big show or something like that. And some final resources. So you're welcome to try this yourself. This is the Influx community is where those quick starts live. It's where the client libraries are. It's where a bunch of other projects are. And then influxdata.com, that's just our main website. Give me 1 second here. And this is all the other links that I normally mention. If you ever have any questions or you're getting started, you're welcome to join our Slack community. Our GitHub Influx community, that's, again, where all those things can be found. The docs, pretty straightforward, their documentation. Blogs, that's normally, again, where sometimes our docs and our marketing team intersect. And InfluxDB University, which is our free learn-at-your-own-pace platform, so you can learn stuff on your own at your own time. And yeah, it's completely free and easy to use. Awesome. So that is the end of my slide deck. I'm actually going to just end it on this, just in case people want to take photos, and if there's any questions.
Thank you, Zoe.